Okay, so let's start by looking at this question you sent. So it says for this, you need to, on the grid, enlarge the shape P with a scale factor 3, center minus 8, 7. So you've started correctly. That's obviously your center of enlargement. Then you've even started drawing on the lines. You're right there. What you need to do is you need to say, if I'm going to make it, enlarge it with a scale factor 3, your shape's going to be 3 times as big, and it's going to be 3 times as far away from this point. So with your ruler, if you put it down on that point and say this, we start by looking at this corner, say, that corner is going to be 3 times as far away from that corner. So you can either kind of look and do a quick measure, or what I sometimes do is I just count. So I say, well, from there to there, you're going 3 across, 1 up. So if we do that 3 times, 3 across, 1 up, 3 across, 1 up, 3 across, 1 up, that corner moves to that point. And then do the same with all of the corners. So if you then go to, say, this corner over here, say, well, to get from there to there, you're going 6 across, 1 up. So go another 6 across, 1 up, another 6 across, 1 up. That corner will move to there. So that's now your the top line of your enlarged shape. And if you go around all of the corners, you'll see that that corner from there, if we look at that one, that's 3 across. And if you do that 3 times 3, then 3, then 3, that corner moves to there. And actually, you don't need to do them all, because once you get to there, if you know it's all 3 times as big, all of the sides are just going to be 3 times the length. So this bit that was 1 square across is now going to be 3 squares across. We'll go to there. This bit that was 3 down is now going to be 9 down. And again, you can check from there to there, it's 4 across, 3 down, 4 across, 3 down, 4 across, 3 down. It takes you to exactly where we thought. This is 1, so that's 3 across, and then it's just going to make up a nice T shape. Ooh. I've obviously done that one incorrectly. That will go to there. Sorry, that point at the top was obviously wrong. It was 6 across, 1 up, 6 across, 1 up, 6 across, 1 up. Yeah, there, I didn't count properly. So that's the shape that's been enlarged with a scale factor of 3. Label that one Q. So stick a big Q on that one. And then part B says, on the grid, rotate shape P through 90 degrees clockwise about the point minus 8, 7. So it's about this same centre again. And you want to turn it. Now, in an exam, what you would do is you'd ask for tracing paper. So take a piece of tracing paper, unfortunately I don't have any here, and trace this T shape onto the tracing paper. And then put your pen at that centre point and just turn your tracing paper 90 degrees clockwise. So your tracing paper's there, turn it 90 degrees so it's upside down clockwise, and in fact your shape should move to, it'll be there. But I would just do that with your tracing paper, just move it along and check where it's going to go and draw it in and label that one R. Right, the second question on this page was the simultaneous equations one. So the trick with simultaneous equations is that in order to solve simultaneous equations, you need to eliminate one of the variables. And I normally look for this second one. And in order to eliminate it, these numbers at the start have to be the same. So in these ones, those numbers at the start are the same. And then what you would do, and you've kind of written it out here, and you've labelled equation 1 and equation 2, so you're all on the right lines. What you need to do at this point is you need to decide whether you're going to add or subtract the equations. So you need to decide, would I add them or subtract them to get rid of these two x's? So this variable or these letters will vanish. So hopefully you can see in this case, if I add them, minus 2x plus 2x would become 0. If I were to subtract them, minus 2x take this 2x would be minus 4x. So in this case, I'm going to add my equations together. So if I add my two together, I get y plus y is 2y, minus 2x plus 2x, that becomes 0. That's correct. This should always be a 0. And 6 plus 0 is 6. So you end up with a statement that 2y equals 6. Well, if you know that 2y's are 6, y must be 6 divided by 2, so y is 3. And once you get to that bit, then the rest of it's quite easy. What you then have to do is you have to substitute this number back into one of these two equations. So let's take the bottom one, for example. So I know that y plus 2x is 0, but I know from here that y is 3. So in place of this y, I'm just going to write the number 3. So 3 plus 2x's must be 0. And then this is just like solving an equation. So if I were to move that 3 to the other side, that becomes a minus 3. 0 minus 3 is minus 3. Move that 2 to the other side, and I get minus 3 divided by 2, which, if you check it, is minus 1.5. So those are your two answers. Y equals 3, x equals minus 1.5. And you just write those in the slot on the exam paper.